Diamonds in Arkansas. If you go far back enough in time, almost every state within the U.S. contains an ancient volcano. One of these ancient volcanoes is located within the state of Arkansas, and the reason this one is especially noteworthy is due to the fact you can legally collect diamonds there. You heard that correctly. The volcano I am referring to is known as Crater of Diamonds, being located within the Crater of Diamonds State Park. The Crater of Diamonds State Park and its associated extinct volcanic vent can be found in southwestern Arkansas, where it is 2.5 miles south-southeast of the city of Murfreesboro. It may be difficult to tell today, but this very site once contained a 2,200-foot wide volcanic crater known as a tuff ring, which may have even contained a small lake at one point. The diamonds within this crater formed long before the eruption which carried them to the surface. 3.2 billion years ago, Earth looked like a completely alien planet, as it had an orange sky, purple oceans, no plants, no animals, no complex life, and the process of plate tectonics may have only recently started. At the time, the area where Arkansas is today contained a piece of crust at ancient craton, the interior of an ancient continent which was unusually thick and cold, being known as a craton. Underneath this craton was a matching piece of unusually thick piece of mantle lithosphere which contained abundant carbon in its elemental form. At higher levels and lower pressure, this carbon crystallized into a mineral called graphite, which is today used in pencils. But as we travel deeper into the lithosphere, the temperature and pressure these graphites experienced continued to increase, until finally it reached a point at 150 to 250 kilometers or 93 to 155 miles depth where it rearranged itself into a better structure for those conditions, becoming the hardest mineral on Earth, diamond. Across the next 3.1 billion years, this thick lithosphere along with its diamonds remained underneath Arkansas. Then, 106 million years ago, Bermuda hotspot as dinosaurs roamed the landscape, something changed. Much of Arkansas was broadly uplifted over millions of years by the same mantle hotspot which would eventually go on to create the island of Bermuda. As the overlying crust slowly moved to the west-northwest, the Bermuda hotspot injected large amounts of molten rock upwards. Some of this magma had a highly unusual composition, having a very low silica content, high amounts of alkali elements, but most importantly an absurdly high gas content.